Welcome back to the Off-Peak, a video series from Charged Fleet covering electric vehicles and fleets. I'm editor and Off-Peak host Martin Ramju. In this episode, we hear from an expert whose business helps auto repair and collision businesses maintain complex vehicles with a combination of diagnostics, programming, and live mechanical guidance from brand-specific master technicians. Artificial intelligence is a big part of their services. I recently talked with Jim Fish, Vice President of Opus IVS, about how AI can be used to better run and deploy electric vehicle fleets. All right, Jim Fish, Vice President at Opus Intelligent Vehicle Support. Thank you for joining us on Charged Fleet's Off-Peak. Good to have you.
Thank you for having me.
So with artificial intelligence, wanted to get into how it is increasingly being applied to maintenance and repair schedules, which I understand is something that your company specializes in.
Yes, it's been being deployed for many years. I know that the craze in the press is of the last few months, maybe the last 6 months since November, but it's been deployed for years, and it really had to do with aggregating maintenance repair orders and understanding what might be going on because of a certain case to really shortcut the diagnostic time. So when you would say, when you look at millions and millions of experiences, you can boil that down to what might be wrong and how do I save time in this and what might happen next time. There's been several approaches to fleet, kind of irrespective of electrified fleet, that are predictive and prognostic in nature. So either predicting when a failure may occur and being proactive about it, or prognostic, like sensing that there's an impending failure, are two ways that machine learning has been in place in the fleet space for some time.
Mm-hmm. So I know AI is a very broad subject, as you were referencing, and it's been around in some forms, but what are some specific ways that it can integrate with electric fleet vehicle usage as opposed to ICE vehicles?
Well, the EV, there's a lot of talk about ICE versus EV and the maintenance going down. And I think to be determined, because really a lot of the repair case on vehicles is at the 5-year plus kind of age, or the 80,000 mile of use plus. And the EV fleet that has experienced that is micro compared to 280 million vehicles on the road. 1% of them are EV at this point, and the miles driven they're now starting to come. But I think that's to be determined, because when you consider many things under car, so tire, suspension, etc., those remain the same. But an EV is inherently considerably more complex electronically than an ICE vehicle. So the module count is the same. So you have all of your other issues that can still happen. So we're seeing less maintenance as our belief in the future, but more expertise to service these vehicles because of the increasing complexity. So AI can help bring the complexity down.
Mm-hmm. Now, how can it be applied to charging schedules? Because with EVs, it's more of a science than it is with just gassing up an ICE vehicle.
Yeah, I mean, first of all, I mean, the hypothesis of EV is if a human can do something without emotional content, then a machine can be trained to also do that. So if you consider millions of vehicle charging cycle experiences, and no human can look at those millions of experiences and be able to formulate the ideal charging plan for a certain condition, a machine can. So when we talk about charging schedules, it's all of that accrued experience that can then be trained into a model that can help understand the ideal charging circumstance for a particular vehicle itself.
Now, we hear also a lot about machine learning. Why don't you just go ahead and define that for us in the context of what you're familiar with, and then
Okay,
how can that enhance the overall management and deployment of a fleet?
sure. So when you say artificial intelligence is the overarching term under which machine learning, so all artificial intelligence is not machine learning, but all machine learning is artificial intelligence, right? So
Hmm.
artificial intelligence is an overall overarching field. And within there are, say, algorithmic things. They'll say, like, the AI says this when it's really actually an algorithm. It can be termed AI. My son is a gamer, and he would say, the AI means that when you turn this corner and you pull up, there's going to be a gunshot come from the left, right? So that's algorithmic, but it is termed AI because it does mimic intelligence via an algorithm. Machine learning, now in machine learning, there's, all forms of machine learning, but within machine learning, there's actually an advanced one called a neural net, and that's where you're manipulating and making multi-level decisions. But machine learning itself, essentially saying that with experience, the input will lead to a different output over time. So the algorithm, as it becomes trained, the same input leads to a different output. So that's essentially, and then there's different ways. There's supervised and unsupervised learning. Supervised merely means that you've given feedback that said, or tagged in some way that has said this or that. Unsupervised means the machine learns on its own, which is a more advanced type field. So machine learning, um, taking these inputs and changing them as outputs. So the more experience you have with either a charging algorithm, but any kind of service algorithm, it can be routing on the road. And Google Maps does this today. I think we don't often think about, like, how many hundreds of millions of gallons of gasoline has Google Maps saved all of us as we use it. I mean, the benefit to society of the massive 280 million vehicle fleet that is the US population that they get from just optimized routing and around traffic now is really, really remarkable. And so in the fleet sense, you can also harvest those benefits.
Hmm. So as the machine learning kicks in, it can provide better insights into deploying fleets in terms of duty cycles, miles driven,
With training,
those.
with training and data, right? I mean, it needs the training, the data, the experience upon which to formulate and optimize things. And the more data you have, the more robust the output will be, and the more time savings, the more cost savings, the more efficiency uh, optimization that you will get. More data in equals higher quality output.
And that leads to our next question about savings in costs and time that result from the increased use of AI in fleet management. What are some
Mhm.
examples that you've seen or that you've heard about?
Yeah, I mean, when you talk about routing, when you talk about maintenance schedules, um, generally, when AI is deployed, and I don't want to draw presumptions into fleet, but generally, the cost slash time savings exceed 50%. They rarely exceed 70%, right? So there is this spot where the business case is clear and robust that we're talking 50% at full implementation. Things like some of the large language models, you're seeing upwards of 80% time savings, but more importantly, you're seeing a quality improvement. So the quality of service, first time repaired. We expect that this is, and there was a research paper by MIT put out about large language models' ability to increase the skill level of people of about zero point 0.4 standard deviations of executional grading of content. So not only do we expect time slash cost savings, but we expect improved executional content. So whether you have, if it's a fleet, whether you have errors in delivery or any error rates, you're going to expect to also go down. But it's not going to make really poor executional best in class. It's going to upskill that because these models respond to your own competence yourself. So when you're using a
Hmm.
machine learning model, it upskills everyone that uses it, but it doesn't make really poor executors great executors. In fact, the research shows that the improvement is about zero point 0.4 standard deviations in executional capability. So really great executors get even better. really poor executors do get better, but about the same on as measured in standard deviations.
Now, with AI constantly developing and changing so much, what kind of advances can we see coming in the next few years that just lead to better support and operations for fleets?
One thing that we're seeing is machine learning is quite prescriptive as an output. It's go for this service, or tires are going to need changing, or rotational. Um, we think the mad rush since the introduction of language models is around a human cognitive assist, and that is not making the decision, but assisting and facilitating a better decision by a human. So that is really what this gold rush is about: is how are you automating and helping humans make decisions better about what they're doing. Routes, if you think about Google Maps, that's very prescriptive. Follow this route. This route takes longer. There might be many other things like that will, you have dilemmas and decisions that are still needing to be made. And some of these models can help you with here's 3 things to think about as you make your decision. So we see this as, and I've rarely seen this put into place, but the things we're working on are in this area about helping humans make decisions, because there are certain places where humans are irreplaceable. Repairing vehicles, it's been very difficult to get a machine to diagnose something that's wrong. These EVs, it's just like debugging code. It becomes very difficult. There are certain things for which there is no replacement for humans, and like repairing vehicles, a machine is probably not going to be able to fish a bolt out of out of an underhood. There's still some very strong human elements, and that's where the productivity advantage lies deepest, is assisting those people further.
So AI could theoretically become like a coach, not just an information provider.
And we think that's what this current mania is really about.
Mm-hmm.
You still have to formulate an ask, so everybody says, "Oh my gosh, like we're not going to need HR people because this thing can write amazing job descriptions," and it's true. But you still have to know what to ask for in the job description, and you still have to edit this job description so it can help you and it can suggest to you, or hey, I would like a series of social media posts. Can you write these? And it will suggest a series, which may or may not be right for your context of business, your objectives, your alignment. And some of that can be made even better over time as you improve the quality of your input to these models. And lastly, there was a great podcast called Recode, and Brian Chesky, the founder of Airbnb, he stated, and I strongly agree with, there are foundation models. You should never develop a foundation model. They cost billions of dollars, but it's the customization level on top of these models, which is the future. So to just a business that says we can be a portal to a model for you, that's not really valuable. The model has to know the context of the person that needs help. And the more that they know, the more this layer is customized, the more value that can be provided.
As you are probably aware, one of the big challenges electric vehicle fleets have is finding enough EV technicians, or at least retraining the ICE technicians. Is there any way AI can help in getting people up to speed, in finding the right ones, and developing a training program? What are some of the
Yes.
options here?
And this is where language models begin to come into play in increasing the skill level. So if you have an A-level technician, which is an elite technician, a diagnostician, if you will, on ICE vehicles, and here comes an EV, he intuitively knows how vehicles are working, and he's going to know that now there's different things to learn on an EV. So can you present him with information that steepens his learning curve, helps him learn more faster in the upskilling? It's a form of training, but unlike any training that's ever been delivered. The training that's been delivered is the modern revolution in training is an online session where you don't have to go to a class with a hands-on practicum. It becomes an online session to save time. It becomes a 5-minute session. It becomes influencers on YouTube. That's the modern state of the art, is influencers on YouTube. The future state of the art is, oh, you have this problem. Here are 6 things that you should do to solve this specific problem. That's where language models can come in and rapidly upskill people.
I know we could go through a lot more aspects of electric vehicles, but that's kind of all the time we have. So certainly thank you for joining us, and we'd be glad to have you back and keep tracking AI as it develops.
Yes, anytime.
Thanks to Jim Fish, the Vice President of Opus IVS, which stands for Intelligent Vehicle Support. Remember to follow and connect with us on social media, subscribe to our YouTube channel, and sign up for our weekly Charged Fleet e-newsletter to stay up to date on the latest EV industry news. I'm Martin Ramju with Charged Fleet. Thank you for joining us, and we hope to see you again here on another superficially intelligent episode of the Off Peak.